Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, everyone, and welcome to the latest episode of the Trend Detection Podcast. Today, we've got a very special guest, because he was once a regular, but I think it's been quite a while since we've had him back on. It's Nat Ford, and we did have this regular series going around the truth around predictive maintenance. So we wanted to pick that up today. Actually, shall I re-record that? Maybe I'll re-record that. I don't know what happened.
Right, that was fine.
Did you drop?
No, carry on.
I'll start again. Sorry.
I didn't drop.
It sounded like a noise. That was all. It put me off. I'll start again.
It was me, sorry. Yeah, it was me. I dropped something.
Hello, and welcome to the latest episode of the Trend Detection Podcast. Today we're joined by a very special guest, Nat Ford. Those who listen to the podcast regularly will know that he's a regular. He's been on many times, and we do it under this banner of the truth about predictive maintenance, where really we're not, as the name suggests, we're not holding back on the real reality of deploying a predictive maintenance platform. And today we're also going along those lines, and we've got a really interesting topic. We're talking about, I guess, the evolution of predictive maintenance. And that sounds very grandiose, and that's going to sort of explain a little bit more what we're doing. But essentially, we're talking about this journey, journey over the past, I don't know how many years, 10, 15, 20 years of condition monitoring tools, all the way through to this predictive maintenance term that's now so widespread, it's everywhere. But now we're moving into this new era of what we might call conversational PDM, which is much more interactive, and it's machine, it's human, and we're getting the insights through chat functions, for example, and copilots. But I'll just hand over to Nat quickly, and for him to do a quick intro and maybe a bit of a background about the topic, because you're the ones who sort of brought this to the table. So over to you, Nat.
Yeah, thanks. No, hi, everybody. And you're right, it has been a while since we did one of these, and I'm looking discernibly older, but these don't. I think when you publish them, there's no visuals, isn't there? So I shan't worry.
No.
Thanks for having me on again. Yeah, I thought it'd be interesting to talk today about exactly that. We've just had this huge launch of a whole new suite of functionality, which is, people say, game changer. I'm not sure what that means fully. I think I've said it, and I don't know what it means fully. But we're moving into the next phase of PDM as we know it. And I think it'd be good to have a little reminder of what underpins all this stuff. Where does it all come from? Because it's all what we talk about in a minute. It's all driven from data, regardless of how complex we get. So I think it's probably worth just having a look back and remember how we got to where we are.
Yeah, exactly.
And importantly, see what the use cases we're actually solving.
Yeah. So let's start at that very, very beginning. I mean, I guess the first question is, people, and I was speaking to one of our colleagues, Natalie, the other day, and we were talking about people who want to jump straight ahead to predictive maintenance. They get excited by the term, but actually there's a real benefit of starting, with condition monitoring and getting data in and monitoring data, isn't there? So let's start with that. What's the the baseline need, I guess, in all this?
Yeah, we don't need to talk about this now, but just to make a distinction. So there's technology and behaviour. And we've talked on this channel a lot before about how predictive maintenance is a methodology. We provide a piece of technology. What we provide is not predictive maintenance. It's technology that underpins that, so that we can refer back to that as we go. But yeah, so let's go back to the beginning. So a machine in a factory or any other environment, but for today, let's say a factory, will periodically break down for a number of reasons, through being used, through wear and tear. And traditionally, somebody involved in maintaining that machine or looking after it or running would get better skilled at noticing when things were changing. And they try and avoid them when they could, but it would just be a natural part of everyday factory life that things would break down periodically, and those breakdowns could be catastrophic. They might completely ruin a whole process, a batch, whatever it is you're doing. It might take your production line down for a day, and so you want to avoid it. So then you start to try and be more intelligent or more focused in how you approach that issue. So if we go back a long time ago, you start to see that you can collect data from machines in one way or another. And for the sake of argument, we talk about sensors. So typically, people would install sensors on machines that would start to look at things like temperature, vibration, torque, whatever was pertinent to that machine. And if you look at those types of that data, all it's doing is describing, a metric from a machine. It's describing vibration. It's describing temperature. It's not telling you anything. It is simply describing. It gives you a way of visualizing or understanding what is happening to that machine in terms of that metric. So then you have a job on your hands. If you want to then start to use that data to make decisions about maintenance, then you have to start looking at that data through the lens of conditions. You want to start thinking about that data as a way of understanding the condition of the machine. So we call it condition data. In and of itself, it's not condition data. It's just measuring a thing that it's measuring. And so this is kind of the birth of condition monitoring. So you're monitoring the condition by using this data, and you're making, hopefully, decisions about to maintain or not to maintain, what needs to be done. But it's very much a real-time exercise and involves people. Nothing wrong with that, but it involves people, and if you've got hundreds or thousands of assets with data coming off them, that's not a kind of valid people task because it takes too much time. How do you take a stream of vibration data every day for every machine and turn it into something meaningful that will allow you to go, I can see this machine is out of sorts for one reason or another and requires some maintenance. So it's a good idea, and people did it for a long time, but it needs to be focused because it's complex and inherently unscalable. So then your next level of evolution is towards predictive maintenance. So the fundamental difference between a condition-based maintenance program and a predictive-based maintenance program is one uses the data that we call condition data to make an observation about the current state of something, and the latter uses the same data to start making inferences or observations about the future state of something. So if you can start to look at the vibration data or the temperature data and say, this data indicates that there is a trend towards or embeds within it a pattern that is recognized that indicates that, in the future, there is going to be this type of failure. Or we don't know what the failure is, but it's going to, moving in a direction which requires attention. Then you can start to say that you're providing some kind of prediction. The term is predictive maintenance, so it's predicting the need for a maintenance intervention. But it's still relying on the same data. So it's still, let's stick to the vibration. It's still got a vibration sensor on a machine that's churning out data, in this case now 24/7, with a nice piece of technology looking at it and making observations, but not observations about now, but observations about what's going to happen. So you're predicting the need for intervention. That's a kind of dumbed down simplification, but it's there's huge complexity to it. And with a solution like ours, you might have lots of cases, maybe 80% of your cases, which say there is change happening and it's an important change you need to go and observe. Or you might get a really complex case that says this is a known pattern of behavior. We know that this leads to X type of failure. And we also know from your previous interventions that these are the kind of things you need to do to mitigate it. And this is the time scale which you have to operate to go and make those changes. So you'll have those range of different types of observations. So it's much more complex, it's much more scalable, it's much more flexible than a condition-based maintenance program by its very nature, because it's using complex technology, not people react to it. But anyway, just to go back to it, that data supports decisions about things you do now or decisions about things that can be done later. And that kind of brings us to our latest evolution, where we are now. So if you imagine If you were state-of-the-art, cutting-edge a year ago, you have a predictive maintenance platform that raises cases, and you make great decisions based on those cases, and you avoid all sorts of nasty things happening in the future. But it still requires you as an individual to look at the cases and apply subjective thought about what may be happening in that context, and to think about the advice that's given by the correct advice, etc., and to decide what needs to be done next. So where we are now, what we've launched most recently, is one of the real use cases, one of the real examples of generative AI being used to continue to add value to solving the problem. So it's not creating funky pictures you didn't need in the first place, or answering weird questions about what's kryptonite. It's addressing the real business need, which is having increasing depth of information about, in this case, degradation to the machine. So what we're saying now is we're evolving from a predictive maintenance platform to a conversational predictive maintenance platform. It is still underpinned by that same data. That same vibration data in this case is pushing through, but now, when a case is raised, the individual who reads that case might scratch their head and say, oh, it's on that machine that I never really understood. I haven't got much experience with it. John, my colleague, who normally deals with that, is out this week for a whole day. He left, he moved on, whatever. He's not available with all that information that's in his head. The manual for this machine is locked away in the office and no one ever reads it anyway. And I don't know what to do. So we've moved, I'd say this huge step change, because now you can literally type into the copilot, help, I don't know this asset very well. What does this case mean? What should I do? Has it happened before? And they're kind of some slight guide for a dummy questions, but you could ask much more complicated questions. One great example that we had from a client was about asking it to take you through the 5 whys, helping to guide an investigation into what's happening with the machine. But the point is, you're no longer in a situation where it is left to you to do the ultimate inference about what this case means and what should be done. You can take guidance from the platform. And the platform, of course, because it's based on ChatGPT in our case, it has all of that knowledge that it's consumed from learning, everything it's been exposed to. But it's also very heavily guardrailed within our context. So it's only going to talk to you about things related to maintenance, but it continues to learn within a client's environment. So this chap, John, is not available today. Everything that he's ever inputted about his activities before is now available for it to learn from and feed back to you in conversational format. And then that next release, you're going to be able to load all of the PDFs, etc., associated with the asset in question. So it can have all these points of reference, everything that it ever learned before, everything it's learned from the context of you as a client, everything that's learned about that specific asset, and it can bring them to bear in a conversational way. So no maintenance individual need feel that they are left alone to make a difficult decision. They're fully supported now by this copilot that becomes, for each and every asset, the ultimate expert. All, however, still underpinned by that same data. So that was so that's a long opening statement, but that's kind of what I thought was interesting to look at, was the fact that, fundamentally, everything we do is based on data, whether it's from sensors or drives or PLCs. That data, more and more complex things you can do in terms of extrapolating meaning from it, and more complicated things we can do in terms of helping communicate that extrapolated meaning in a way that's helpful for people. That now.
No, exactly. Yeah. End of podcast. No, I think we can dive into some little bits and pieces. I was making some notes as you were talking there. I think the first thing is around that sort of first step, because I know you said the predictive maintenance bit to conversational predictive maintenance doesn't sound like such a massive step, because it's almost an advancement of the same thing, but making that leap from just monitoring the condition of machines to then predictive maintenance, both, and we know it's not just a technology thing, it's also a cultural thing and all that. But could you just describe that sort of jump between that first so, people monitoring individual machines to like maybe looking at a predictive maintenance program?
Yeah, I mean, if you think that the goal that you're trying to achieve in any of those stages is to drive down unplanned events, increase your uptime, and become better in your maintenance program, then if you're an individual who's in stage one, just looking at data, then you've got this incredibly arduous task ahead of you, because you have to open up whatever is the platform that you're looking at this data in, or get someone to come around once a month and take a handheld reading from a sensor, and then come back a week later and give you some insight to what that data means. There's various different ways of doing it, but you're still going to have to pour through that data and try and make decisions about which machines seem like they might need in some kind of help. So it's not going to go very far in terms of improving your overall maintenance approach. So as a result, you're still going to have a very heavy preventative maintenance schedule, where you make some assumptions about what might happen to machines and what work might need to be done on them in order to avoid those outcomes. But really in quite an unguided way, apart from where you can afford the time to pore over condition data. But then if you go to the other end of the scale, you've got a system which is, let's say you've got 100 machines that are being looked at, 1,000 machines. It might have cases on 5 of them where you know now that either there's some degradation happening that needs attention, or some other known failure mode that something's moving towards. But you can also tell across all the fleet of all the other machines that they're in good fettle, and they do not have any sign of wear or damage or degradation or known failure pattern that they're trending towards. So you can also make some very sage decisions there about other things that you don't do. So you can now, as an individual, have a look at the overall maintenance plan and start to reduce those preventative interventions. Reduce the amount of things that you do because you don't know what's happening, and therefore you have to assume the worst. Changing oil because it might need changing. You can have a much more focused approach on working on things that do need to do. You can also start to challenge. You can challenge the statements made by the OEMs. They might require you to do maintenance on a particular cycle. And you can push back and say, I want to reduce these interventions from every 6 months to 12 months, because what we see is that it's not required. So the difference is exponential, because it takes an individual to now pay attention. Instead of the 1, 5, 10 things, I can pay attention to thousands of things, because I focus on what it is they need to look at. And now with the interface, with the things that they do decide to focus on, they're not left to try and work out what activities to be involved in. They can have a full-on dialogue with the platform to decide what those required activities are going to be.
So, yeah, no, it did. It did. And what's interesting, or what I'd like your view on that actually is that sort of the conversational side. Is that, do you think that's making predictive maintenance more accessible to the market? More easy to not grasp, but sort of implement in their own. I'm not thinking of the right word here, but can't think of the word. When you adopt, that's the word. Sorry, it took me a time, but adopt a solution. Will it increase adoption of predictive maintenance?
Yeah, I mean, so 2 things. First of all, yes, I can't see how it won't. Secondly, there's all sorts of things that we don't know culturally, but we're at a stage where we're all beginning to use these kind of platforms, and we're evolving the way that we do it. We're evolving our propensity for it, or for some people might be increasing their reluctancy to. So we don't know where that's going to end culturally. What we do know is that if you're an individual working for a company and you do a job which is physical, and you're out there, you're maintaining, you're managing stuff, you're walking the line. Sometimes we have people when we go and have meetings who have to get changed and have a shower before they come into the meeting, because of the nature of what they're doing. they don't necessarily have time to pull off a massive glove and try and start inferring meaning from a platform. And so, people are very often reluctant to take on new systems, etc. So you need to make these things as simple as possible for them so they extract the value without being challenged by the overall concept. So these individuals who might be reluctant to do so, they have a system now where they can be opaque. They can say, help, I've only got 5 minutes. I need to know what this case means. Can you just explain it to me in 5 bullet points that I can then repeat to my line manager or my colleague or to the engineer that I'm meeting this afternoon? This is really tricky, but all of my colleagues speak Polish and I don't. I got seconded here to look after this line, but can you translate it into Polish? So, all of those things which might make someone feel intimidated about using the system are taken away because you don't need to go in as the expert who's going to pull the meaning out as the expert and communicate it. You can literally say, and I'm sure most people won't do this because most people do have some level of expertise in their job. But say you found yourself being first line support for an OEM who provides some kind of system and you're supposed to be reacting to cases that come up for third parties who've got your machinery, and you don't know what it means. You can say, I don't know what this means. You need to tell me what this means so I can start to give instructions to people. That's like a really bad. That's a scenario that shouldn't happen. But if it did happen, it'd be catered for. If that's catered for, then all the people who are in a slightly more normal scenario are going to be catered for too. So yeah, I've used this example before. I should probably stop doing it because I shouldn't denigrate myself. But there's an expectancy for people like me to be able to demo the platform, and I never did because I was used to say, "It's not. I'm commercial. I'm selling the platform. Why should I demo it? I'm not the expert in demoing it." But I love demoing it now because I can use natural language to make inquiries. That's easy to demonstrate, and if I can do it, then anybody who's worried about it should be able to. I'm going to try answering your question again a bit more directly. Quite often we meet teams who are a bit intimidated by technology, and this means they don't have to be.
Exactly, and actually, it's not just for maintainers and people who use the platform. It's even for someone like me. I know a bit more about the platform now, but just anyone who logs in for the first time, in reality, could start using it and understand it pretty quickly. With little guidance. Yeah. But one because we did the live event and you mentioned the live launch last week. But one way our colleague Dan, who responsible for the product, described this sort of evolution as well within the platform is that because we also have summaries within cases now. So before we had graphs which you need to interpret, we now have summaries which someone can just go into a case and see, oh, that's what's happening, great. But now the next level is this interactive side of it, and I love that little journey he described, of the platform's evolution, and it's like any change in the platform, like we discussed last week, it's all around user feedback, and that's where the functionality will go next. It will all be based on how our users use it, and that's the exciting bit now. Customers, sorry, not users. Well, they are users, but preferred customers. How our customers will use it will now define what happens moving forward, which is really exciting.
Exactly, and we'll find that out over time from them. But what you mentioned is an interesting part of that evolution because it sits within one of those chunks of change. But you're right; it's very much the idea that previously there'd just been a graph, right? And that graph might describe the change in vibration. But a lot of people don't like graphs. If you're colorblind like me, they're usually configured so that you can't work out which thing you're looking at anyway. And then, yes, you're right. The interim phase would describe the graph, which is great. But now with this massive step onwards, you don't need to think about graphs. Just ask it what happened with the vibration and what it means. Why did it happen? What's going to happen next? What will happen if I don't do anything? Yeah, it's a huge step onwards.
Yeah, no, it is. It is. It quite clearly is. And I guess I know we're sort of zooming back because we're focused on not the end of the journey, but the current point of the journey, I'll call it, because there's probably a lot more to come. But if you're someone sort of monitoring your doing condition monitoring at the moment, how long would you expect that journey to take? If you're monitoring a small number of machines and actually want to look at a more scalable program, like predictive maintenance program, like how long would that journey from there to there sort of take? I know it's hard to answer. How long is a piece of string, you might say to me?
Well, I listened to a call recently, which was between two existing clients because they wanted to share some best practice. And one thing that was quite clear is that the journey doesn't end, because where's the end point? You can't say, "Oh, look, we did predictive maintenance. We've done it." And usage will. I think when around about the time that we joined the business, there was an expectation you'd have lots of users, and that users would be a metric that you could use for saying whether it succeeded or not. And then we re-understood that and realised that it's the information and people going onto our platforms are relevant. You want people to take the data out and use it, and our clients realised that as well. So that was part of that journey. And then you want to be able to expand across more things. That's part of the journey. And then you want to be on more sites, and then you want to have more of a culture of using it. And at the point where you might say, "Oh, we've done it. We've onboarded predictive maintenance. We're using it." Then pesky companies like us go and launch a new version that's got Gen AI. So then you now need to start thinking about the implications of that, and what else can you now that makes you more operable. What else do you do? So I don't think there is an end, really. Maybe you could argue the end is when you get to the point where all of your maintenance decisions are made based on the output from a predictive maintenance platform, but you can still continue to do it better, to do it faster, to get more out of it, to push us to develop more features. So I know it's a slightly waffly answer, but I don't think there is an end to it.
No.
You start and you're in learning mode because you're trying to work out if it works in your environment. And there'll always be other things you want to onboard that you're trying to learn about, whether it works for those things. And can it be onboarded? When it's onboarded, does it raise cases which are relevant? Can those cases be understood? And when you act on the cases, does it affect a change? There's going to be a never-ending cycle of those questions across the things that you do. We're just making it easier to say yes to all those things.
Yeah, exactly. Exactly. And so I guess if we sort of round it up at the end from where we are, so we've talked about those different stages. I'm not going to ask you the typical last question of any podcast, which is what's going to be predictive maintenance in 5 years' time, because that's quite impossible to say. But how do you? I guess if we focus on where we are now in terms of the Gen AI and copilots, etc. Where do you see that?
No, I'm going to go back to your question. You didn't ask the question, but let's imagine you did. Right? We've taken advantage of generative AI. We didn't invent it, right? So it's out there. It's like the internet. It's like whatever. It's all pervasive. And the culture, if we shut shop now, the culture would continue to onboard and use that technology in different ways. So 5 years from now, 5 years is a huge amount of time in terms of the evolution of this stuff. Think of all things like our knowledge platform. So one of our competitive advantages is that we've taken everything we know about best practice for, choosing assets, choosing sites, deploying, using. We've encoded all of that, so it's available as workshops and training, etc. All of that's available for our platform to learn from and to inform on. So we might go from conversational predictive maintenance to guided predictive maintenance, or informed, or I don't know what the terms would be. We're not there yet, but we might make it so that you log into the screen and you log into the platform and simply have a dialogue. And the dialogue might say, "I noticed that you haven't onboarded these other assets. Here's my recommendation. This is what you need in terms of data," to take us back to the start point of this conversation. At some point, you want this intelligent front end to start guiding you on data selection and fulfilling the circle. So I suspect, we're not going to stop. We're going to keep pushing and keep developing and taking advantages of the new waves of stuff that come, things which get developed, and people get used to using these kind of interfaces and copilots. I think it's exciting, isn't it?
No, it really is.
Like I wasn't very excited. It is exciting, but and it's sort of beyond our control. So it's not, it's not an R&D function. It's a react and develop function, isn't it? Because as new technologies become available to us. So let's see what the next onion layer will be. Condition monitoring data, condition-based maintenance, predictive maintenance, conversational predictive maintenance, and then some kind of guided predictive maintenance.
Excellent.
Excellent. Didn't ask a question, but I've asked it anyway.
No, David, you've completed the journey. That'll be. We'll put a pin in that one for the podcast in 4 years' time or 5 years' time to talk about that. But I'll just finish as well, because we started talking about data and condition monitoring data. So one thing to really take away as well, you don't need, especially for when we talk about the conversational PDM, you don't need lots and lots of data to get started with this stuff. I guess is also an important message, because I know there's a lot of concern about, we need to collect loads of data, and I guess a lot of customers have by now collected data using sensors, but actually we don't need lots of data to get started with this. It really can make an impact on just small amounts of data.
Absolutely. Yeah, people used to think this was a big data issue. It's not. It's a horrible little bits of data issue, which we can extrapolate condition indicators from. As long as enough data to encode some kind of condition indicator that can be tracked over time, then you can start to provide a function. And the more intelligence we wrap around it now, the more likely you are to make really good inference from small signals.
Absolutely. And yes, what a good way to finish. So keep an eye out. Actually, we might even link to it, because I know we've talked a lot about the Copilot and Gen AI today. Like I've mentioned a few times in the past week, we've released a few new sort of videos and white papers around this topic. Because obviously it's of great interest to the market and customers and colleagues even alike. So we'll link some of those resources in the chat as well, so you can read up on that. But I think for now, thank you, Nat. We won't leave it as long next time. Thank you for sharing your thoughts with the audience, and thank you to everyone at home or wherever you are for listening. Thank you very much.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.